Now, let's continue. Let's continue with the second type of mapping, which has to deal with exponential. Now, we dealt with the linear one, where to start with, you make sure there's a constant difference in the codomain and the domain. So two factors have to be determined for it to be what considered as a linear mapping. That is what we establish in the linear. This is very important to me because going forward, we will be what building on those facts. So please, if you haven't watched the linear mapping, watch that before watching exponential. And notwithstanding, you can actually watch this one too, because this is actually a separate method also. But unless you understand the linear one, if you understand that one, you can move here. You can still watch this one. Now, what is supposed to be considered under exponential? So for the linear, two factors has to be considered: the constant in the difference of the codomain and the domain. But when it comes to exponential, let's read first. Now we are saying that a mapping is said to be exponential if the ratio between consecutive, when we say consecutive, that's one element, one number to the next one. There's no jumping. So that's the meaning of consecutive. Maybe I didn't touch on this in the linear one. So consecutive element moving next to the other, next to one another, next to the next next to another. That is it. No jumping or hopping. That is what it means. Now, we are saying that it's said to be exponential if the consecutive element in the codomain is constant. The mappings in illustrated example below are exponential mappings. The rules of such mappings are of the form, this is a general form, so y is equal to AR or raised to the power x minus b, where a is the first term of the elements in the range or codomain. By now you know what range in the codomain are. Now, and b is the first element or the first term of the elements in the domain, and r is the common ratio of the elements in the range. No worry, I told you I'm going to read first and then explain all this, which sounds like gibberish. Now, so the first factor there's only one factor to determine. So, and that factor is what? There should be a constant, right? Constant in the what? The codomain. There should be a constant ratio. So this is what I was trying to avoid earlier by not using the term ratio. But when you say ratio, basically is what? The dividing one number by another, and the answer that you get is a ratio. So it means here that we are going to, but what is important is which of the elements or the items are going to be divided to get the ratio. So it means that the items to be dealt with will be different. So in the linear mapping, we were looking at what? The difference, right? The difference is the codomain over the difference in the domain. That gave you the ratio. But here, the ratio is only within the codomain, and it has to deal with what? The numbers next to one another. Next, so here next, here next, here next. That's what it means. But here we are dealing with what? This one. The ratio between here. So that's what it means. It's as simple as that. Now, if you realize, I've written the general formula, and then I have come down to explain how to get the ratio. And the ratio we are saying is in the codomain. So when it's in the codomain, it basically has to deal with the y values or y elements. So what it means is that take y2. This is y1, y2, y3, y4, y5. That is the assumption or the calculation. So if you see me write y2 over y1, it means that when 4 is divided by 1, what is the value? When 16 is divided by 4, what is the value? When 64 is divided by 16, when 256 is divided by, that is it. So it's rather the bigger y over the smaller y, bigger y over the smaller y. So y2 over y1, y3 over y2, and then y4 over y3. And that follows the sequence, right? It's just what? The sequence. So with that established, so with this example, for instance, if I should divide 4 by 1, the answer is 4. let's continue. By dividing 16 by 4, what is the answer? It's 4. Dividing 64 by 16, what is the answer? It's 4. So you realize that the difference is constant. And that's the factor to check. If they are not constant, or they are not the same, then this violates the rule of what? The rule that falls under exponential mapping. It's as simple as ABC. But in the linear one, you were checking two factors. Checking in the difference in the codomain, and then checking the difference in the what? The domain. After that, we found the ratio between the two. And then we use that value as A to put into the general formula to find our whole formula. That's what we did in the linear. Now, here we are checking the ratio in the constant ratio in the codomain. The codomain has to deal with the values of y. So with that established, which we have found here for instance to be 4, now we keep that 4. So it means that the ratio is 4. Now we will look for other variables, right? So hence let's look at this one and come here to do the real calculations, right? So let me push it down a bit. So now that we have the general rule is that we are saying that the general rule is that y is equal to ARX minus B. So where A is equal to what? 1, right? So we are saying that A, what do we say A is? We are saying that A is the first term of the elements in the range or codomain. So with this formula, with this question given, which one is A? A is 1. And which one is what? B. B is 1. Checking that ordered set of pair, ordered pair, right? So I think I was going off the camera. So using this form, this general question given, we have A. We are saying that A is the first term of the elements in the range or codomain. So that is 1. So A is 1, and then looking for B. Where is B? B is the first element, the first term of the elements in the what? In the domain. So domain, that's 1. So we have seen Y. Sorry, we have seen A and B. A from here is simple, and that is determined from the question given, the mapping given. So we have 1 and 1, which is the A and B. This, so you get the A and B from the what? The mapping given. This is not rocket science. You don't have to be thinking outside the box. Come and find it, A and B in the formula. So if you have found it, so it means that our focus is rather on R. That is it. Our focus on R. So in the linear mapping, our focus was on what? A. Our focus was on A. B just came up with the rules or the other variables given, and it was very easy. So the focus in the linear was on A. Now when it comes to exponential, the focus is on R, because A and B are given in the question. So that is what it means. So that now let's look for R. And the R is how we went around with the ratio between what? The codomain or the Y element. That's what we did. Good. So now that we have that, we came back to the general formula given that y is equal to AR raised to the power x minus b. So we put that A is 1, B is 1, and R was what? Given 4 over 1, and then 16 over A. We just tested some of them. It's just what it means. We tested some. We didn't have to test all of them, but we tested. So when you tested, all gave to be 4. So it means that R is 4. If R is 4, now come back and put them in the formula. So with what? We have A, this, times the 4, which is the R. Now X comes, and then Y comes. The B comes. Putting them appropriately, we have the general formula to be Y is equal to 4 raised to the power X minus 1. Simple. And this is applicable with the formula. That's it. So we can use the same thing to test for the II and III. That is it. So you realize that I told you that the important thing when it comes to math is the concept. With the concept, you can do practicals. And that is it. So we will end here. Watch the videos, pause, check them carefully. If any questions, let us know. We'll see you soon. Bye for now.